Good day everyone, this is Manef Marilia from class A13 and today we will discuss one problem about atomic spectroscopy. This problem came from the book of Skoog, The Fundamentals of Analytical Chemistry, 9th edition. Let's get started. The copper in an aqueous sample was determined by atomic absorption flame spectrometry. First, 10 ml of the unknown were pipetted into each of 550 ml volumetric flasks. Various volumes of a standard containing 12.2 ppm copper were added to the flask, and the solutions were then diluted to volume. So this is the table that we're given to the problem, and we will use this value to answer the following 7 questions that we need to find the answer for it. So let's get started. The first task that we need to do is to plot the absorbance as a function of the volume of standard. Therefore, the volume of standard will be our x-axis and the absorbance is our y-axis. Using Excel, we can plot the data earlier that is given in the problem. So here it is. This is what the graph looks like. It is the function of y, or the y is also given here, but we will also solve for it later on. So this is the graph. This is the task that we need to do in task A. For letter B, we need to derive an expression relating absorbance to the concentrations of standard and unknown, and the volumes of the standards and unknown, as well as the volume to which the solutions were diluted. First, of course, we know that the absorbance is the product of molar absorptivity, path length, and concentration, because that is equation 24(8), which can be found in the book of the Fundamentals of Analytical Chemistry, page 660. So, but we have here two samples, which is the standard and the unknown. Therefore, will the total absorption of the solution is the sum of the absorption of the standard and the absorption of the unknown. S is the standard, X is the unknown. So, we also know that the observed absorbance can then be converted in a corrected absorbance by taking into account of the volumes, which can be observed in this formula. We will now put this equation to the second equation that we have here. So we will have this. We just need to multiply the corrected absorbance to the second equation that we have. So we just need to make the molar absorptivity times the path length divided by the volume, or the total volume, which is Vt, as our K, or the constant K. So the answer for this question is, this is the K, so we just need to make that K, so we will have this equation. This is the answer for the second question. Moving forward, for task C, we need to derive expressions for the slope and the intercept of the straight line obtained in A in terms of the variables listed in B. We know the line, or the equation of the line, which is y is equals the m, or the slope, x plus b, or the intercept. So, and we also know we will use the equation that we got earlier, which is this value. We know that the volume of standard is the x-axis and the absorbance is the y-axis. Therefore, the absorbance is the y and the volume of the standard is the x. So it is clear that in this equation, KC or KCS, or the concentration of standard, is the slope, and this whole term is the intercept. And that's the answer for the third question. For the fourth question, show that the concentration of the analyte is given by the relationship Cx is equals to BCS divided by mvx, where m and b are the slope and the intercept of the straight line in A. We know that it is given Cx is equals to BCS divided by mvx. Now we just need to put the values of b and m, which we were able to solve in letter A in the equation of the line. We just need to put that value, and we now have this equation. We will use this is now the answer for our task D. Moving forward to the fifth task that we need to do is to determine the values for m and b by method of least squares. So I use this manual method so that we can understand on how Excel gave us the equation of the line of the graph of earlier in A. So what we have here, the n is just the number of the samples that we have, x is the volume of standard, y is the absorbance. So we need the x squared of that, and we need the product of x and y. Then after getting those values, we need to get their summation or their total to each other. Then we have this guide for us to know which where we put them. So bn plus mxt is equals to yt. B here is the intercept, n is the number of the samples, m is the slope, x is the total of x, and y is the total y or the summation of y. So what we have here is we just need to plot those values, the values on the yellow one to this. So 5b plus 100m is equals to 1.892. We have a second equation, which is b summation of the x plus m, which is the slope, times the summation of x squared is equals to x times y summation of those two. So we will have, putting the values on the yellow one to this equation, we will have this 100b plus 3000m is equals to 46.65. Now solving simultaneously, we will now get the value for m and for the value of b, and that will be our final answer for task E. For task F, calculate the standard deviation for the slope and the intercept in E. This I use the problem itself is an Excel problem. So I use Excel to use this to get this answer. So this is the plotted um, I plot the given data that we have earlier in the problem, and to determine that value we need this formula, which is the Linus. So and this will now give us this. It will automatically give these values. So what this question asks us to find is the standard deviation of the slope and the intercept. So, and this is the standard deviation of the slope, and this is the standard deviation of the intercept. And yeah, you just need to use Excel for this for a faster solving of it. Now, for the last question that we need to answer, we need to calculate the copper concentration in ppm copper in the sample using the relationship given in D. So this is the relationship that is given in D. Cx is equals to B Cs divided by mvx. So we just need to put the values that we have. For the intercept, we solve for it, which is 0.2022. Multiply that by the given concentration of standard in the problem, which is 12.2 ppm. Divide that by the slope, which is 0.00881, and the volume of the unknown, which is 10 ml, which is given in the problem itself. So we just Multiply and divide those, and we will have 28.0 ppm as an answer. And that's it for learning task number 3. Thank you.